Here you've got an example where they are giving you two equations and they want to know what is the area enclosed by those two curves. To find the area enclosed by two curves, this is really an integral setup. It's a definite integral setup. The formula looks like the integral from a to b of whichever equation is on top minus, in parentheses always, whichever equation is on bottom. Whichever one's above versus whichever one's below. Kind of as you think through the regions, this would be the top because it's above the other one on the bottom here. The beautiful thing about this problem compared to another one we've seen is we can actually use our calculator on this. So we're going to talk through how to use our calculator to make this type of problem pretty straightforward. The key on this is going to be to start off by graphing these two equations. So we're going to start by putting these equations into our y equals. So the first equation we're going to pop in to y1, we're going to put x cubed minus 8x squared plus 18x minus 5. And then in y2, we are going to put the second equation, which is x plus 5. And what we're going to find by graphing this is two things. We are going to be able to visually see which equation is on top and which equation is on bottom. Then we're also going to be able to find our bounds, because our bounds are generally going to be the intersects of those regions. And conveniently, our calculator can calc those intersects for us all day. So we're going to start by grabbing our calculator, go into our y equals, and then we're going to pop in this equations. So in y equals, we're going to get x to the third minus 8x squared plus 18x minus 5 in y1. In y2, we put our second equation, x plus 5, and we graph that. So the interesting thing here on this problem is you can see we actually look like we have two regions. We have region 1 right here, where the blue graph is above or on top of the second graph. So the blue graph was our y1 graph, that's our x cubed graph, and the red graph is our x plus 5. So we've got one region right there, and then we've got a second region right here that we can see, which is this time the red graph, x plus 5, is on top, and the blue graph, the x cubed graph, is down below. So that means you're going to have to set this up two different times, one for each region, and in the end, we add those results together. So we know right now, so how I come through this is I would say, okay, I'm going to have region 1 in that area. Remember, as we looked at that picture, in that region, the blue is above the red. So the x cubed is on top and the x plus 5 is on bottom. So what we've got going on here would be top x cubed minus 8x squared plus 18x minus 5, and then minus the one that's on bottom, which is x plus 5 dx. So that's region 1. And then we got to come through and do the same thing for the second region. And when we looked at region 2, these two things flip-flopped position. So in region 2, the x plus 5 graph is on top, and we're going to subtract off of that again, so minus parentheses this entire equation, 18x minus 5 dx. So we have set up now our top minus bottom. That's the first thing we want to do. Now what we're going to do is we are going to come through and we are going to find the intersects of those graphs so that we can find our bounds. So to do that, we open up our calculator, kind of move this to the side a little bit so we can see some of what we're doing. We need to find one intersect here, a second intersect in the middle, and a third intersect at the far right side. To do that, our calculator is very good at finding intersects. You're going to hit the second button, which is in the top left. You'll choose the Calc menu, which is the button at the very top above Trace. Inside that menu, you can see the number 5 option says intersect. So you scroll down to the number 5 and you hit enter. From there, it's going to ask us a series of 3 questions. The first 2 questions you could really care less about. It's saying, is that the first curve? It's on the first curve automatically for you. Go ahead and hit enter. It'll switch to the second curve and say, is that the second curve? Yep, that's our second curve. Go ahead and hit enter. It's the third question of the guess that really matters here. The cursor is always going to find the intersect that it's closest to. So we are closest to the one on the left right now, so we can actually hit enter a third and final time. It'll say the word intersection at the bottom of the screen. You'll know you're right, and whatever that x value is, that's going to be what you're looking at for your intersect. So the left side, the lower bound on this first region here, is going to be x equals 1. So we come in, and we know what our lower bound is on this one. That's 1. We now go find that next intersect. So we start the process over again. You're going to hit second, and then calc, and then again choose that number 5 option, intersect, hit enter. It asks us for the first curve, we hit enter. It switches to the second curve automatically and says what's the second curve. We go ahead and hit enter on that. The guess again is the most important piece. We now want to guess closer to that middle intersect. So we scroll our cursor to the right so we're close to that middle intersect, and we hit enter a third and final time, and that gets us an intersection of x equals 2. So the interesting thing about that intersect is that is the top intersect, the upper bound for our first region, but it is also the lower bound on our second region. So we're getting 2 for the price of 1 here. So our upper bound is 2 on region 1, and our lower bound on region 2 is 2, because they connect at that point. So that makes sense. Then we need to go find our third and final intersect. So again, we start the process. We hit second, calc, choose that number 5 option, which is intersect. Then from there, first curve, yep, hit enter. Second curve, yep, hit enter. And then guess, this time we're just going to scroll up to the right so we're close to that far intersect there. And we hit enter a third and final time. It says the word intersection and shows us our x value for that intersection at the bottom. So the upper bound on region 2 is going to be x equals 5. All right, so we have our two integrals set up. We'll end up adding their results in the end, but now we need to get those results. Again, the beautiful thing about this is we can use our calculator. Our calculator can find these integrals for us. And so now what you're going to do is you're going to go back and put that full equation into y1 on your calculator. So we go back in now, go to our y equals, and this time we want that x cubed minus 8x plus 18x minus 5 is the top, and we're going to subtract off the bottom equation. So minus, always in parentheses, our bottom, x plus 5, and then I'm going to clear out that other one. So we graph this, and now to find that integral value, you hit the second button, and again choose the calc menu at the very top, and you're going to scroll down to that number 7 option this time, which is integral of f of x dx. How awesome, right? Hit enter on that. It's again going to ask us a series of questions. The first question it wants to know is what's your lower limit? Well, the lower limit is going to be your lower bound. So on this problem, our lower bound was 1. So you type in 1 and hit enter. Then it's going to switch and ask you now for the upper limit. Well, the upper limit on region 1 is a 2. So we type in 2, hit enter. It colors in our graph for us here, and it tells us there's our region, and it gives us our answer 0.58333333 out on the bottom. For some people's classes, that might be acceptable. You could just use that rounded, oops, we don't need that much calculator. You could just use that rounded value. Sometimes on these, though, they want these things to be fractions. And the cool thing about your calculator is it could turn that into a fraction for you. So we can hit second quit to get out of here. And then if you go into the math button and hit enter on number 1 fraction, it is taking the answer, which is what we just got out, that integral value, and it's going to turn it into a fraction for us. And so it tells us that that fraction, that number is actually 7 over 12. So we know the answer for region 1 is 7 over 12. And now we got to go back and just play the same game for region 2. So we're essentially just going to flip-flop the position of our two equations. So now the top equation for that second region is x plus 5. Then we're going to subtract, always in parentheses, our second equation, x to the third minus 8x squared plus 18x minus 5. We graph it, and again we hit second, calc up at the top. We choose the number 7 option, integral. It wants our lower limit. Our lower limit on this one is 2, so we type in 2 and then hit enter. It then wants an upper limit. Our upper limit is 5, so we type in 5, hit enter. it shades it in and it gives us 11.25 out. So our answer for that region is 11.25. Again, we could turn that into a fraction if we want to. You go second quit to get back to the home screen. Hit the math button and again choose that number one option, fraction. It'll take that answer we just grabbed and turn it into a fraction. So we get 45 over 4. So our second region is 45 over 4. From here, we now go ahead and just add those two values together, and that's going to end up giving us the total region bounded by these two curves. So we get 7 divided by 12 plus 45 divided by 4. We hit enter. It gives us some funky decimal. For some people, that might be enough. In case you need it as a fraction, again, you just hit the math button. Oops, that's not the math button. Math button, and then the number one option, fraction, and then hit enter, and so we get out of there 71 over 6. So the total region bounded by these two curves, which ended up being two separate regions that we had to bring together, was 71 over 6. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.